Hello, and this is Miranda Andrew Gordon, here to teach you about logarithms. This is your worksheet before you. Let's learn about logarithms, and we're going to be reviewing it today so that I can teach you all of the rules and the explanations behind the rules on how to solve logarithmic problems. Okay, so our first section is evaluating logarithms. And we have two rules under this section. The first rule is that when a to the b equals c, log base a of c equals b. This rule is easier for me to remember by something that Mr. Knights taught us, which is that the base stays the base and the other two switch around. You may have heard this before, and if you haven't, what it means is that the a, which is the base here on this side, stays the base when you switch it into logarithmic form, because as you can see, the exponent is b, which means that the base is a, and in logs we call this little subscript number down here the base, which means that, as I said before, the base stays the base. Now, to the other two switch around part, you can see that here the b is by itself, and here the b is with the a. Here the c is by itself, and here the c is with the a. That just means that whatever is with the a, or the base before, will be by itself when you switch it to the other form. This works going both ways, and it's an amazing little rule. It's what most other rules come from. You can derive a lot of other rules from this, so remember this little rule and you'll be pretty good to go with logs. Now, our second rule is log base a of b equals log of b over log of a. And this is used more with calculators because when you input a log into your calculator, you can't change the base. The base for a log is, as we'll learn later on in one of our other sections, is usually base 10. So if you don't see a base, for example, if I just had log of a equals b, the base would be 10 because if there is no base present, it's assumed that the base is 10. What this means is that when you can't change the base in your calculator, you need to input something else into the calculator that's equivalent to log base a of b, as long as that base is not 10. So what we do is we take the higher number and put it over the lower number, which is another easy rule to remember. What's high stays high and what's low stays low. What's high goes in the numerator, what's low goes in the denominator. It's as simple as that. So now, over to our explanations. We have a little example here. Log base 25 of 25 equals x is our given. So what we're going to do is use our little rule that we have over here, and we're going to switch log base 5 of 25 equals x to 5 to the x power equals 25. And we can do this because, as we learned before, the base stays the base, which we can see here it does. The 5 stays the base in both the log and in the exponential equation. And the other two switch around. So we can see that the x, which was once by itself, is now with the 5, and the 25, which was once with the x, is now by itself. And then from there, we can just simplify because we know that 5 to the x equals 25, and we know that 5 squared equals 25, so we can clearly see that x is equal to 2. On to our next section. So, evaluating logarithmic and exponential expressions base 10. What you need to know. Log of a equals log base 10 of a. This is all that I was saying before, which is that it is assumed that the base of the log is 10. Like I said, this just means that since we don't see a base here, we can assume that the base is 10. Log of a equals log base 10 of a. They're exactly the same. another rule. Log base A of B to the C equals C log base A of B. This is another very helpful rule. You can see that the C was once the exponent and is now the coefficient on the log. This is what Mr. Knights usually refers to as the exponent to coefficient rule. It's very helpful in certain situations. I recommend that you memorize this rule because it will certainly help you out pretty often. And this is another simple rule. Log base A of A equals 1. This just means that, I guess you can think of it as almost canceling out. The A's sort of cancel each other out and they become 1. Don't confuse this with them becoming 0. Log base A of A is always 1. So to our explanations. Log of 10,000 equals x. This is our given. So log of 10 to the 4th equals x can be derived from this because we know that 10,000 is equal to 10 to the 4th. This is not a logarithmic rule. This is just a simple number to exponential form transition. It's not logarithmic at all. Now we can see that we have 4 log of 10 equals x. And this is going back to the rule that we learned before, log base A of B to the C equals C log base A of B. We're just taking the exponent and making it the coefficient. And you'll see why this becomes helpful in the next step when we learn that, we can see that there's a 10, the 10 is the number on the log, so we can see that the base must be 10 too, and as we remember, the 10s then sort of cancel out almost and become a 1, so we're left with 4 times 1 equals x, and so we can see that 4 equals x, just because 4 times 1 equals 4, and that's it. Now we can move on to our next explanation. So we have what might seem like a much more complicated problem here, which is 10 to the log of 7 equals x. That is our given. And this seems much more complicated because you might be saying to yourself, but we haven't seen anything like this before. There weren't any rules with, what to do when the log is the power on a number. Well, that's not necessarily true because although we haven't seen something that exactly had the log in the power, we do have a rule that can help us out here. So that is the first rule that we learned, which is A to the B equals C when log base A of C equals B. So we know that the log is in the power and we have a 10 base. So what we're going to do is convert this to logarithmic form from exponential form. So the 10 stays the base. Remember, the base stays the base. So we're left with the 10 in the base here. And the other two switch around. So the log of 7 is going to come to the other side, and the x is going to come next to the 10. So we're left with log base 10 of x equals log of 7. And remember that even though this 10 wasn't here before, we know that it must be base 10 because there wasn't previously a base present. So we can see that we're left with something quite simple where everything is the same except for the x and the 7. So it's obvious that the x is equal to 7, and that's just simplifying. Now, on to our third example. Evaluating logarithmic and exponential equations base E. So you only have one rule for this section, and that is that log base E of x equals ln of x. So just remember that a ln is equivalent to a log base E. Now, our given in our explanation here is ln of ln of e to the 7 equals x. So now we can see using our log base e of x equals ln of x rule that we can convert this ln into log base e because they're exactly the same. So all we do here is change the ln into log base e, and we're left with this equation here, log base e of e to the 7 equals x. Now we can see using our rule here, where we take the exponent and make it the coefficient, that we're left with 7 log base e of e equals x. This is a very good place to be in. This is why I recommend that you memorize both of these rules, especially because then we're going to sort of, as I said before, sort of like canceling these e's and turn it into a 1. We're left with 7 times 1 equals x, so we can see that 7 equals x. Yes, so that's all for that example. Now we're on to a much more complicated section, which is transforming logarithmic graphs. Now this section is harder even for me, so I hope that you'll understand everything that I'm saying, and I just hope that it makes a lot of sense. But if it doesn't, I recommend that you contact me or contact Mr. Knights for some help, or review this table for practice purposes. So, your rules. The first rule that we have here is log of x plus a is a translation of log of x, a units to the left, where a is greater than 0. I'm going to stop there because there are sort of two rules in this first rule, and I'm just going to go over the first part with you. So what this means is what it said, but in simpler words, that if a is greater than 0, meaning if a is positive, and you add it to x in the parentheses, it is a translation of log of x, the regular graph log of x, of a units to the left. So just remember, no matter what else is going on in the equation, this part here, this a, if it is positive, will translate the graph a units to the left. On to the next part. If a is less than 0 or negative, it is a translation of the absolute value of a units to the right. So just remember that it is not negative units to the right, which is essentially to the left. It is the absolute value of a units to the right, which, say, if it was -3 was a, then it would not be -3 units to the right, which is, again, essentially 3 units to the left. It would still be 3 units to the right. On to our second rule. A plus log of x is a translation of log of x, a units up, where a is greater than 0. This means, similar to what we said before here, that when a is greater than 0 or is positive, it is a translation of the graph of log of x, a units up. So remember that it's sort of the opposite here, because when we had a positive thing, a positive number in our first rule, we went to the left, which is sort of the opposite of what you would think, because on a graph, the positive part is on the right. So it's, in our first rule, it's like the opposite of what you would think, but in our second rule, it's exactly what you would think, where when it is positive, it goes up, which seems to make more sense, and is a translation of absolute value of a units down, where a is less than 0 or negative. So again, the same thing with the absolute value. Please do not think that it is a units down, which would essentially make it go up. It is the absolute value of a units down. Now, onto our third rule, where log is log of ax, where the a is multiplied by the x. Do not confuse this with added to the x. It is a horizontal compression of log of x by a factor of a, where a is greater than 1. And is a horizontal stretch of log of x by a factor of a, where a is greater than 0 and less than 1. See here, we don't have any negative numbers, because we will get into what the negative numbers do in a later rule. But we simply have numbers that are greater than 1 and numbers that are between 0 and 1. There can be no negative numbers multiplied by the x. Well, there can be, but again, that comes in later in a different rule because it is essentially a negative x, as you can see down here. So what we have here is, again, a horizontal compression of log of x when a is greater than 1. Again, the opposite of what you would think, that when it is greater than, you would think when it is greater than 1 that it would stretch, but it is a compression for something horizontal, and it is a stretch when it is less than 1 and greater than 0. So remember that horizontally, it's the opposite of what you would think, and vertically, it is exactly what you would think. Now, on to our fourth rule. A log of x is a vertical stretch of log of x by a factor of a where a is greater than 1. Again, this is what you would think when it goes vertically, because when a is greater than 1, you would expect it to be a stretch, and here it is. And it is a vertical compression of log of x by a factor of a where a is greater than 1, or greater than 0 and less than 1. Again, it's what you would think, where here it isn't. So be wary of that. Try to remember, which is which. And now we have our fifth rule. Log of negative x is a flip of log of x over the y-axis. This is where I was saying that here you can't really have a negative number, because if you multiply a negative number by x, you're left with something that is essentially negative x, because, that's the rule. When you multiply a negative number by a positive number, you're left with a negative number. So it doesn't really matter where the negative is, whether it's on the a or the x. X is essentially negative. So whenever there's any negative number in front of the x, or x is negative, it is a flip of log of x over the y-axis. But be careful, if it is a negative number multiplied by negative x, then it is positive. It is not a flip of log of x over the y-axis. Under our last rule, negative log of x is a flip of log of x and these things, which are what you would expect, is that the a in the things that are what you would expect are outside of the parentheses. They're in front of the log. And that is simply because when you can here divide by a, and here you can subtract a, and then they would be on the left side of the equation with the y. In the equation y equals log of x. So it would be, y minus a equals log of x, or y over a equals log of x. And so that is why essentially it's the opposite of what you would expect for these and not for these, because it really is, it's hard to explain, but it's that when it's on the side where it belongs, which is like if it was on the left side of the equation, it's always the opposite of what you would expect. I don't want to confuse you here. If you're better off remembering simply that horizontally it's the opposite of what you would expect, just do that. Whatever works for you remembering. So now on to our explanations. Our given is y equals -3 log of 7 minus 2x. And using our horizontal compression rule, that it is a horizontal compression of log of x by a factor of a, where a is greater than 1, when we have the equation log of a of x, we can see that the 2 here is what's going to be the factor of compression horizontally. It's that simple to describe. I don't believe that you will be expected to draw the graph, but if you are, we will have an example of a graph later on in this tutorial. Okay. Oh, I'm sorry, you couldn't see that. Okay. Pardon my unawareness of that. Okay. So again, what I just said, since you couldn't see it, I'm sorry. It is a horizontal compression by a factor of 2 because there is a 2 here. Ignore the negative again because it is essentially 2 times -x. And it is a horizontal compression of log of x by a factor of a, where a is greater than 1, 2 is greater than 1, so it is a horizontal compression. Now we have a flip across the y-axis because log of -x is a flip of log of x over the y-axis, and we have a -x here. A translation of 7 units to the left because we have a 7 here, and log of x minus a is a translation of log of x a units to the left, where a is greater than 0, and is a translation of the absolute value of a units to the right, where a is less than 0. 7 is greater than 0, therefore it is a translation to the left of 7 units. Okay. Now we have a vertical stretch by a factor of 3 because a log of x is a vertical stretch of log of x by a factor of a, where a is greater than 1. Therefore, it is a stretch vertically of 3 by a factor of 3. A flip across the x-axis because negative log of x is a flip of log of x across the x-axis. Again, those are a lot of rules to remember, but I hope that you can find something that will make sense to you. If you want more explanation on why things are always the opposite of what you would expect, feel free to contact me. Ask Mr. Knights during class, something. Just speak up if you don't understand so that you can get help, because it's more important to get help on something that you don't understand than to, feel like you're not embarrassed because you don't understand, if you understand what I'm saying. Okay. Now, and again, because there's no reason to be embarrassed if you don't understand something. I'm sure that there are plenty of other people in your class who don't understand the same thing. Yeah, I don't know. I'm sorry. I want you to understand. Okay. So expanding the logarithm of a product. What you need to know is that log of a, b, c equals log of a plus log of b plus log of c. What this means is that log of 25 x to the third y to the seventh can be expanded because we have different factors in here that can be turned into separate logs. But first what we're going to do is see that 5 squared equals 25, and we're going to just turn that 25 into 5 squared so that we have exponents on all of our factors here. Then we are going to use our rule that we just learned, and we are going to separate the logs. So we have log of 5 squared plus log of x cubed plus log of y to the 7th. And then we are left with using our rule here, the exponent to the coefficient rule. And we are going to take the exponents here, the 2, the 3, and the 7, on all of our factors and make them coefficients on all of our logs. So what we are left with is 2 log of 5 plus 3 log of x plus 7 log of y. And that is our answer. Now, on to expanding the logarithm of a quotient. What you need to know is basically the opposite of the rule that we just learned, which is that log of a divided by b divided by c equals log of a minus log of b minus log of c. Notice that the log of a is not negative. That is because the a is not being, it is not in the denominator, so it is not negative. So here we have our given for our explanation. Ln of root 3 x to the 6 plus 27 over y. And what we're going to do is use a simple rule here that is not logarithmic at all. Root a x equals x to the 1 over a. So what we're going to do here is take this and make it so that the root 3 is the power on the x to the 6 plus 27. So we're left with ln of x to the 6 plus 27 to the 1/3 over y. And what we can get from there, after we use our rule here, is ln of x to the 6 plus 27 to the 1/3 minus ln of y, because we have taken the denominator and made it a negative ln of its own. And see how our rule has a log in it, and this is a ln. Remember that ln is just a log with a base of e, so all of log rules apply to lns. I just wanted to point that out for you. Okay, now what we're going to use is our exponent to coefficient rule, and we are going to take the exponent on the x to the 6 plus 27, make it the coefficient, and we have our final answer. Now we are going to condense a logarithmic expression. So our given is, I should point out that we don't have any new rules with this section. So now let's move on to our example. So our given is 5 ln of x minus 3 ln xyz, ln of xyz.